Hello, this is our next video on linear models, and our learning target is still I can create tables and equations that model real-world situations when given the scenarios. Our success criteria is the same as before. I can identify and label the important information. I can create a table using the starting value, which we also call the y-intercept, and the rate, which we can also call the slope. I can write the equation in slope-intercept form that models the scenario and table, but our extension activities are going to be a little different. We're going to be able to graph the equation on our calculators, our inspires, and use the calculator features to display the y-intercept and the x-intercept, and then also create just a basic sketch on the paper of the graph so that we have a better idea of what it's doing and what it looks like. And then also to interpret the meaning of the key features, both the intercepts, the x and the y-intercept, and the slope in the context of the situation by pulling them out of the equation with our labeling, and also by looking at what the graph is telling us after we've created our basic sketch. So here's our first problem, and these problems are a little bit longer than the ones that we've done before, and we're still going to use the three reads to model them. So it says a tank holds 200 gallons of water. A pump is draining the full tank at a rate of 25 gallons per hour. That should say per hour, so I'm going to change that. Create a table and write the equation that models this situation. So that's our first read, and from there we just sort of get a general idea of what this problem is about. It's about a tank that's got water in it and they're draining it. Okay, now for the second read, that's when we go back through and we put our slash marks at the periods. Some people also put them where the ands are and if there's a comma, but for right now I'm just going to do the periods. And then we read each little section and pick out important information. This is the second read. A tank holds 200 gallons of water. Now what's mathematically important from that is the 200 gallons of water, so I'm going to go ahead and write that down. And I'm going to make myself a note that this is what the tank holds. And that's the first sentence. I'm going to mark through it just to remind myself that I've read it and I've pulled out the important information. Second section, a pump is draining the full tank at a rate of 25 gallons per hour. So what's important there is the 25 gallons per hour. And please, again, don't just write down the numbers, write down what they mean or what they're for. So 25 gallons per hour. And I'm also going to write down that there was an important word in there, and that's that the pump is draining. Okay? That'll be important later. But it's always important if they give you directional words, words that indicate that something is increasing or decreasing, going up or down, that you also write them down as part of your label. And I'm going to mark through that. And then the last thing just says, create a table and write the equation that models this situation. Well, one of the things that I need to do is to pick out my rate and my starting value. Okay, now I'm just going to remind myself over here that my rate words are per, each, and every. And if I see one of these words, that indicates a rate. So I'm going to go back and I'm going to look at what I wrote down. And I can see where I wrote down that there's a per in there. So I'm going to circle that. And then the number that goes with it is the 25. So I'm going to label that. That must be my rate. 25 is my rate. Okay. And then remember, the rate always goes with the x. So down here, I'm going to put the 25. I'm going to put the 25 with the x. Now, x is not the rate. The 25 is, but they all always go together. So I'm just going to put them together. And then if I want to know what the x represents, since the 25 goes with it, take that per and figure out what is that for. It's 25 gallons per what? Per hour. So The hours is what the X values represent. And if you look at the table, it's always X first and Y second, and that also agrees. X is the hours. Now the starting value is how much is actually in the tank at the start, and it says that the tank is full, and we know that the tank holds 200 gallons, so this must be our starting value. Now I'm going to look at actually the table, and I know that when I have an X value of 0, I'm going to highlight it right here, that's where my starting value belongs. So I'm going to put my 200 right here. I'm going to label that as starting value. And here's where it's important to know about that directional word, that it's draining. To go to the next one, like how much water is going to be left, I got to realize that the water is decreasing. It's going down. So I'm not adding 25. I'm really subtracting 25. So I'm going to put like a minus 25. So really over here on the rate, it'd be good to label that as the minus or negative 25. And then I can just figure out the next number. So 200 minus 25 is going to give me 175. And then I need to do it again. I'm going to subtract or go down 25, because remember the rate is what happens over and over again. So then my next number is 175 minus 25, which would be 150. And then I'm going to do it again. So then minus 25. So then 150 minus 25 is going to give me 125. And I should be able to go back and look and see that, yes, it is going down by 25 each time. Now, when I write the equation, I'm going to start off with my y equals, and I'm going to remind myself that we always put the mx first, or the mx go together. They don't actually have to always be first, they go together. So that's why it's good to have that negative 25 with the x. And then the b comes after that. Since it's positive, I can do plus 200. Now you can also write it in reverse order, but then the negative on the 25 becomes a minus sign. So what you're saying is you started with 200 gallons of water and it was draining, that's why it's minus, or decreasing by 25 gallons every hour. Now one thing that's good or important to know is that sometimes you don't always have x's and y's in an equation. They can use different letters. So if we just go back and look at what our table says it represents, the y is gallons, so a good letter for that would be a G. The X is hours, so a good letter for that would be an H. So we could easily see it be written quite frequently instead of the Y and the X, something like G equals negative 25H plus 200, meaning the gallons of water in the tank are decreasing by 25 gallons every hour, and it started with 200 gallons of water. So we can easily, a lot of times, see it written instead of with X's and Y's with different letters, but the letters should represent what we're talking about. Now we're also going to create a basic sketch. So here's my x-axis, and I know that before the x represents the hours. Here's my y-axis, and the y was representing my gallons. And I also know my y-intercept, because remember, this b value, I'm going to do it in a different color. This starting value, this b, is my y-intercept number. So I can see it here, or if you wrote it like this, and we also labeled it over here. The starting value is always your y-intercept number. That's why this is called slope-intercept form, because it uses the y-intercept. Since that's a positive 200, I'm going to put it way up top here. And since I know that my slope is negative right there because it's draining, I know that the water level is decreasing and it's going down like that. But it would be good to actually have a model of this on our calculator. I'm going to show you how to do the calculator in a different video right after that, but if you don't have a calculator and you want to be able to find out your x-intercept, I'm going to show you how to do that on paper. I'm going to go back to the original way we wrote the equation. Y equals negative 25x plus 200. And I'm going to remind myself that if I am on the x-intercept, that means I'm looking for the x number and the y is a 0, because that would be, if I look over here at the y-axis, that would be at the 0 on the y-axis. So I know that my y number is going to be a 0. So instead of the y here in the equation, I'm just going to put a 0. The rest of it I'm going to leave the way it is. But now I have a very simple little equation that I can solve. Okay, I need to get the x by itself. And I've got this 200 with this, and it's negative 25 with it. Well, you always move the things that are further away or connected with a plus or minus first. So I'm going to move the 200. Since the 200 is positive, you use opposites. That would be a minus. And what you do to one side, you have to do to another. So 200 minus 200 makes the 200 go away, which is what you want. Now it's on the other side. And 0 minus 200 is negative 200. And then I just bring down both the negative and the 25x. And now I have to get rid of the negative 25. And if we notice that there's nothing in between the 25 and the x, if there's nothing in between, that's the same thing as a multiplication dot. So then the opposite of multiplication is division. And when we divide, we're going to divide by the whole number, so the negative 25, the whole thing. And I have to do it on to the other side as well. And negative 25 divided by negative 25, that's going to cancel. So we're just going to bring down our x. And then we have negative 200 divided by negative 25. And we should remember that a negative divided by a negative is a positive, so then we end up with 8. So then this number right here this number right here ends up being an 8. And I know that that's an 8, and this is hours, so it's 8 hours. So what's happened is it started with 200 gallons of water up here, and then 8 hours later, there's no water left in the tank.